welcome to Enots Engineering. I'm Alan. In today's video I'll be looking at 4 changes that I've made to the lathe that I think have improved it, and I'll be showing you some tips. So let's go into the workshop, see how we do it. The belt I have on this is a T-link belt, and I fitted it in 2017, so it's been in use for 7 years and I've not touched it. So a T-link belt looks like this. The links are held together with these little T pieces, and it's easy to remove. So all you do is, when they're locked, so they're across the belt, and to unlock, just twist it to that position. What you can do is bend the belt up and over to undo it. Do it on the second one and take a link out. Or if you wanted to add a link, you can put these back in. But you must remember to turn them so the locking pins are across the hole. Otherwise that could come back out again. It's not affected by the oil. I haven't touched it for 7 years, so we'll take the top off and have a look at the belt inside. On mine I have 4 screws on the top to undo, and this plate should come off. You can see the belt on the pulley. If I just turn it round, this is normally covered in oil inside here, and there's oil on the pulley. You can see the belt hasn't been affected, still turns, it's not slipping. Now before you ask what length it was, I forgot. It was 7 years ago. All I did was take the old belt out, measure the old belt, and then ordered new belt, but just a few inches longer in case I needed any spare links. So that looks okay. This is one of the items my father made for the lathe. Fits on here, goes through there, fits on there. 2 little studs in the front to hold this piece. You can still change the gear. You can get the gear inside, put it into back gear if you need to. But this is useful for putting things like micrometers, measuring equipment on there as you're using it on the lathe. Now that's over 50 years old and it still works. It's always been on the top of the lathe. I'll give you a small tip. If you have your cutting oil in a tin like this with a brush, I used to find that if I put it on the lathe, sometimes it would fall over, you'd lose some of your oil. So what I do now is I have a small magnet. I think this magnet's off the inside of a hard drive for a computer. You just take the magnet because they're really powerful magnets, and I have one of these grip lock bags. Just put the magnet in the bag, seal it in, then fold that over, and I just put that on the bottom of the tin and just take the bag off to remove any swarf that's stuck on the bottom. Then when I put the tin down, it's not going to tip over. So you can put that tin anywhere you like on the lathe and it won't tip over. My second item is the lamp. It's the same lamp holder and bracket and everything. The only difference is the bulb inside is an LED. Why change? Before it was a 12-volt bulb, and to supply the 12 volts there was a transformer on the lathe. I'll show you where that was. So if you move down to the cabinet, this hole here had the transformer in and just a switch. The transformer looked more like a transformer out of an arc welder. It was massive, and all it did was transform 240 volts down to 12. So if you change to a LED lamp, you can buy a small 12 volt LED driver, and it was about the size of a couple of cigarette packets and that's right at the back inside. If I go lower in. Now if you look in there, the back on the left, you can see like a white box just here. That is the LED driver for the LED lamp. That is a switch. And all this space here took the transformer. And now what I have in there is my inverter for the digital motor. So the LED lamp was my second tip. The third one is this inverter. As you can see, it's quite small, fits in that space. This is the original on-off switch on the left. This is a pendant control. I just made it to fit. Where the lathe bed bolts down onto the cabinet, I just put a piece of sheet steel. Made a piece of steel that goes on the back of the control. That just slots in there, so I can move it if I need to. So this is the pendant that comes with the inverter. You have start, stop, forward, reverse, run or jog, and then speed control. Now the speed you can vary. So if I start it off and slow it down, you might be able to hear it squealing. It doesn't like that speed, it's a little too slow for the settings. So just speed it up a little bit. And we'll have a look at the speed on the chuck. That's the speed on slow. It's showing 108 revs per minute. But on the inverter it's saying 156. You can see how slow you can go. Now if I wanted to go slower, don't forget you've still got the drive belts underneath. I very rarely change the drive belt from the position that it's in. But if you want slower and more torque, you can just change the belts down to get the slowest speed, and that will give you even slower. So speed wise, I can go from that up to that's the stop. I've programmed the controls so this should stop after 3 seconds. So if I press start, it will go up 3 seconds to get to speed. When I press stop, 3 seconds to stop. Also on the control pad you have forward, reverse, run or jog. So if I switch it into reverse, stop it, forward, and you have run and jog. At the moment it says run, so if I click it over to jog and press, you see it just steps a little bit and stops. And if I click it on reverse, it does the same in reverse. Now we'll have a look at the motor and the cabinet underneath. One little tip, I use a tray underneath the chuck. This is just an ordinary baking tray or cooking tray, and it catches most of the swarf, makes it a lot easier to clean your lathe after you've used it. Now in the cabinet below you can see there's the original pulleys. Now before I had the inverter and the motor, I thought, well, maybe you could get away without using the pulleys, but they are useful. 90% of the time it's at that speed set there. I can go faster if I need to, and if the motor starts to complain, I can drop the belt down to a slower speed to improve the torque on the motor. That motor, I don't think you can't really see much of it, but it is an imperial motor. You can get metric or imperial. This one's imperial. That's the motor. The only problem I had with that motor was the length of the spindle. I had to pull the one pulley back a bit because it would mean the motor would be virtually touching the cabinet. You can see in the plastic cover I fitted some holes in the top and the bottom. That's for air circulation. Up to now it's worked perfectly well in there. There's enough air circulation in the cabinet from the main motor, and that's just in case. And the switch for the lamp is on the left hand side at the top. But on the inverter you do get a lot of readings and information there if you need it, like the speed. So if I work the lathe, you see there the speed. When I slow it down, .98 RPM. That is the motor speed, not the chuck speed. And it's just squealing there. 94. But that's the top speed is. Now the speed shown on the inverter is the speed of the motor, and obviously if you have belts and pulleys the speed could be higher or lower than that's shown on the inverter. This is the next item, the digital readout. This is an X and Y digital readout unit. There are two scales fitted on the lathe. That's the scale fitted to my cross slide, and there's another one at the back down here along the bed of the lathe. You can face off the end of a bar and zero the position, so your tool is set to the end of the bar. On the Y side you can turn a bar, measure it, set the size there, and then you know what size the tool is cutting as you turn more material off the bar. You can also set the angle of your compound slide. You can convert from metric to imperial just by touching a button. This one's a calculator button, so you can use it as an ordinary calculator. You've got sine, cosine, tangent. Then there's lots of other features on here. Some you can use on the lathe, some are for a milling machine. Well, that's my 4 items and some tips. Hope you enjoyed it, and we'll see you next time on Enots Engineering.